Okay, I think this is always what we studied last time, right? We come up with a data set of 3 observations with the red points. And then you come up with the predictive points, the green one, and you get the difference between them to get the residuals. And you compute the square, you compute the sum of the square of the residuals to get the error, right? You may say that is the error square, and this expression is a function of k, because k is a no parameter and xi, yi are given. Then you get the value of k, which is 120 divided by 189. That is in this case, we consider the model. We consider the model y equals k times x. Okay. If you consider the simple linear regression model, let's say y equals a plus bx, then you get these formulas for a and b. Okay, and we use similar arguments. We need to consider the error, which is the sum of the epsilon of the ei squared, right? That is what we did, and we minimize the errors to get the value of a and b. That is okay. That is what we studied last time, I believe. All right. That's true, everybody. It is okay. It is okay if that's what we studied last time. All right. That's what we studied last time, everybody. Hello? Is that what you studied last time? Hello? May I move on? Okay. So now I will remind you what you study in linear algebra to get a result, the coefficients for the case of linear model. So what we study can be applied for general cases. So you can apply that for nonlinear models, right? For nonlinear regression model. What if you have a linear model? If you have a linear model, then even if you have a multiple linear model, you can use linear algebra to get the answer. Okay. So I'm going to give you another approach. Let's consider the following model. Suppose that you get y equals a plus bx. Let's say y equals k times x. Then this is a linear function. You already knew that, right? What if y equals a plus bx? Then you can say it is a z plus bx, where z is always 1. Okay. Then we have another function, another linear function, right? We have a linear function in that case. So let's say we have this one. Hello, can you hear me? I don't know if I can hear. I can hear you. Can one student turn on your microphone and tell me?
Yes, I can hear you, teacher.
Yes. No, it seems that I cannot hear you. Let me see. Maybe I'm going to leave the meeting and then try to join again. Excuse me. Can you hear me, everybody? Can you hear me? Is this okay? Okay, very good. All right, so let's have a look at this. You see that y is ac plus bx. Then y hat is azi plus bxi. All right. So if you rewrite this equation as an equation of matrices and vectors, you can come up with y hat, right, equals a times zi plus b times xi. Or you may say the matrix zi xi times the vector ab, correct? Okay. So you come up with the following. You can get the following expressions. Besides, you can see that you get the error. That is the sum of ai squared. And if you consider the square root, then you can get the square root of a1 squared plus en squared, right? So this is simply the standard Euclidean vectors in the product, right? So I can say this is the norm of the vector e squared, not squared, where the vector e is the vector of the components e1 is to en. All right. So you want to minimize this one. And what is a, by the way? ai is yi minus yi hat. Therefore, a is simply y plus y minus y hat. So this becomes y minus y hat. Do you understand that? And if you want to minimize this one, the error, you want to minimize this now. Okay, so what we want to do is to minimize, we want to minimize the distance between y and y hat. Okay, so you want to find the coefficient a and b. It means that you want to find y hat, the vector y hat, such that this the distance is minimized. Okay, so you want to minimize this one. Yi is given, right? Y, vector y includes all the observations. So you knew that. How about y hat? Y hat is the vector of all these components, right? So you want to find y hat that minimize this distance. Okay? Do you understand what I'm saying? That's all clear? Okay. So you can see that. Suppose that this is the error, and you get this sum, right? You get this one, right? And you want to minimize the error, and you get the y hat, which is this one. And if this is a, and this is k, then you have a times k, and you want to minimize ak. You want to minimize you want to minimize the distance, right? Y minus y hat. Okay, and if you want to minimize that, then it is obvious that y hat is the projection of y on the column space of A. Why is that? Because y hat belongs to the column space of A, right? Y hat is the linear combination. It is A times Z plus B times X. So it is a linear combination of the two columns Z and X of the matrix A. So y hat is in the column space of A, right? And y is a given vector. Suppose that you get the vector y, and you want to find a vector on the column space of A, which is closest to y hat. So you want to find the projection y hat of y, right? Y hat is simply the projection of y on the column space of A. And if you remember what you studied in linear algebra, you should know that the projection of the vector y on the column space of A satisfies this equation at times A times k equal at times y. Okay, where A is this matrix and k is this vector. Do you understand? Is that clear? So you can try the following set. Okay, now suppose that y equal k times x, then A is simply the vector of x. You get 5, 8, 10, right? And at times A times k equals at times y, equals 2, 5, 7. Then you can solve for k and you get this value. Okay. If you get y is a plus bx, okay, and then you can say it is az plus bx, where z equals 1. Then A is the matrix 1, 1, 1, 5, 5, 8, 10, and you get at times A times k equals at times y. And you can solve for the vector AB, which means that A is minus 3 and A is minus 3 and B equals 1. Then you get the equation of y equals minus 3 plus b plus x. Do you understand? And that is actually what you got last time. Do you understand, everybody? Is that all clear? Is that okay? If that's okay, may I move on, everybody? Okay, very good. So there are two ways that you can use to determine the coefficients, right? You can use calculus 1 to minimize the function, okay? To minimize the function, to minimize the error, right? And then you get, and then you can get the answer, and you can apply this one for any kind of function, okay? Can apply it for all functions. You can also use linear algebra to get the projection of the vector, okay, on the column space of the matrix A. All right, and you can apply that for just linear model. Okay. Okay, now I want to go back to the model again. I want to study further. You get y equals, let's say, a plus alpha plus beta x, and then I get yi equals alpha plus beta times xi. Okay, and then you can approximate alpha and you can approximate beta. And remember that you should have the epsilon I, where epsilon I is a random variable. It is the random error, and that follows the standard student normal distribution with the mean 0 and the variance sigma square. Okay, is that clear? Is this all right, you guys? Hello? All right, so you get epsilon I follows this normal distribution. So in order to, now you want to construct a confidence interval for alpha and beta. In order to do that, you need to know the variance of the approximations, because you approximate this one by A, you want to approximate this one by B. So if you want to get a confidence interval, you should say, okay, beta equals B plus or minus the error, right? The error, and then the error of B, of course, and this is B plus or minus, let's say the t value times the standard error, okay? And this standard error, in order to get this standard error, you should think of the variance of the of B, right? And if you compute the variance of B, you must know the variance of the random error epsilon I. So anyway, I want to approximate sigma square. So how can you approximate sigma square? Let's say you want to approximate it by the S square, right, as usual. And what is that S square, by the way? Well, sigma square is the variance of epsilon I, and you can approximate epsilon I by the EI for sure, right? Epsilon I is the random error, the random vector, and that is the random error. And the residual is the EI. So EI is what you observe, the error you can observe, and epsilon I is the random error. Okay, so you can use EI to approximate epsilon I, and therefore, if you want to approximate sigma square, you should think of the average value of the EI square, because the variance is the sum of the squares of the deviations, right? So it is the sum of the square of the deviation, which is EI, and you divide that one by the degree of freedom. So I should use the this is the sum of BI square, so it is simply the error, right? So I call it the SSE, the sum of square for error. So I get the SSE divided by the degree of freedom. What is that degree of freedom? When you compute the sum of EI square, you need to know EI, and in order to get EI, you must know yi hat, right? You knew yi already, but you need to find the yi hat, and yi hat is a plus bx. So you need to know the value of a and the value of b. You need to estimate two parameters here. Therefore, the degree of freedom is n minus 2. Oh, by the way, yn, because there are n observations, so the degree of freedom initially is n. And you approximate two parameters, therefore the degree of freedom is n minus 2. So I come up with the S square. And this is an approximation of the sigma square. Do you understand, everybody? Is that clear? That's all right? Okay. So you can find the S square, and you can use this S square to approximate sigma square. All right. On the other hand, so S square is simply the SSA divided by n minus 2, and SSA is the sum of AI square, and that is the sum of yi minus yi hat square. There is another way that you can use to estimate this sum, to estimate the SSA, by using the total sum of the derivations. So I want to introduce to you the sums of squares. Okay, so you get the SAT. Suppose that the mean value of y is 4.6667. Then you can find the sum of the squares of the derivation yi around the mean value y bar. So you get the yi minus y bar all square. So you get yi minus y bar square, and this find the sum. You get the SAT. Okay, you get the SAT. If you compare the difference between the predicted value and the observed values, you should get the residual, right? And the square, the sum of the square of these residuals give you the SSA, the sum of square for error. And if you compute the derivations of the predicted values on the green dots around the mean value, then you get the SSR, the sum of square for regression. So we can get the following sums of squares. So you get the sum of squares of the residuals is the SSA, which is this one, the total sum of squares of the response variable, SST, and the sum of squares for regression, you get the SSR. Okay, then you can see that this value equals this one plus that one, right? So the SST equals the SSA plus the SSR. Therefore, we come up with the following fundamental identity. Okay, is that all clear, everybody? Besides, if you remember what we studied up last time, you should see that the SYY is the sum of yi minus y bar square, and it is equal to this. So you can use that to find the SST, because in fact SST is the sum of yi minus y bar square, and that is the SYY. Okay, it can be proved also that SSR, the sum of square for regression, equals B times the SSY. You don't need to compute this sum, all right? You just see that it is B times SSY. You already knew the value B and the SSY, so you can get the SSR very, very quickly. And you look at the difference between these two sum of squares to get the sum of square for residuals. So because you see that if you know this value and that value, then you can solve for SSE quickly, right? It is the SST minus the SSR. Do you understand? Is that all clear, everybody? Okay, as I said, it can be showed that the mean of the SSA is this. So you can use the S square to approximate sigma square. All right. Moreover, the main idea is that you minimize the SSA. Okay, you want to minimize that, so you want the SSA to be close to 0. So you want this ratio SSA over SST to be close to 0. So if I consider R squared is 1 minus SSA over SST, or let's say it is the SSR over the SST, then we expect r squared to be close to 1. All right, so if it is close to 1, that is good. All right, if r squared is close to 0, that is bad. Do you understand what I'm saying? Is that all clear? Is that all right, everybody? It's okay. 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 Now I think it's we are ready to move to how to construct a confidence interval, right? Okay, so I will start with the slope. All right, you can see that you can find the mean value of B. You can prove that the mean value of B equals beta, right? You can also find the variance of B, which is sigma squared over the x-axis. So this means that that B is an approximate bias estimate. Of beta, okay, and the variance of B equals sigma squared divided by the x-axis, all right, and from here you can approximate this one by s squared divided by the x-axis, okay, and this one is simply the SB square, right, and you get the SB square equals that, and SB is simply the square root of s squared over the x-axis. All right. So if you standardize B, you should get B minus beta divided by the standard error divided by SB, and this ratio follows the standard distribution with degree of freedom n minus 2. Okay, and from here I can say that beta is simply B plus or minus the error, or let's say T times the standard error for B, where SB is the square root of s squared over the x-axis. Do you understand, everybody? Is this okay? Is this all right, you guys? Is this all right? Okay. We can also get a similar result for the y-intercept. This is what we get for the y-intercept. You can find the mean of A, which is alpha. It means that A is an unbiased estimator of alpha, right? So that is a good approximation. And the value of A is sigma squared times mu xx over the xxx. And the mean of that one is 1 over n. The mu xx is 1 over n times the sum of xi squared. So the value of A is this expression. If you remember the values of A, you should see that it is sigma squared divided by the xxx. That's all. Now the values of A is the values of A times the mu xx. All right, times the average value of xi squared. If you approximate sigma squared by the s squared, you should get s squared times mu xx divided by the xxx. Okay, and this is simply as SA squared. Okay, so SA is the square root of s squared times mu xx over the xxx, and you come up with this one. All right. So we can see that if I standardize A, I can come up with A minus alpha over SA. Okay, and it follows the standard distribution with a degree of freedom n minus 2. Is that all clear, everybody? Is this all right? Okay. So we can find and we can use this one to get a confidence interval for A. So I get alpha equals A plus or minus the t value times the SA, where the value t can be obtained by using the t distribution. All right. Therefore, we can come up with the following confidence interval for the coefficient. Okay, you can get confidence interval for A and for B. You can also perform the hypothesis testing. Why do you want to talk about that? Just like y equals alpha plus beta x. All right. And you don't know if beta equals 0 or not. Let's say the approximation is y equals 5 plus 0.5 times x. Then you can use the value of x to predict the value of y, right? However, if the exact parameter beta equals 0, then x has no effect on y, or let's say y does not depend on x. It means that you cannot use the value of x to predict the value of y, right? Understand? And x plays no role in computing the value of y, so you can use that to predict anything about y, right? That's why you want to check the hypothesis, the alternative hypothesis that beta is not equal to 0, and the null hypothesis is usually beta equals 0, right? And in order to do that, you need to consider the statistic B minus the right-hand side 0 divided by the standard error, right? We usually want to care about beta instead of alpha. We don't, in most of the cases, we don't care about the hypothesis alpha equals 0. We don't care about that most of the time. But we usually want to talk about beta, okay? So this is what we have. Understand what I'm saying? And you come up with this one, and you can consider you can find the rejection region, right? This is let's say this is alpha over 2, and that is alpha over 2, right? And then you can get the acceptance region, and you get the rejection region. Understand? And then if T belongs to the acceptance region, we fail to reject the hypothesis. It means that the slope could be 0. If T J belongs to the rejection region, then we can reject the null hypothesis. It means that we that X has some effect on the value of Y. Is that okay? Okay. So this is what I just mentioned, hypothesis testing. Let's consider the following example. Please think about that for a few minutes. Can you get the answer? Can you get the answer, you guys? Okay, it seems that you got some values. I'm going to share the Excel with you so that you can see all the steps I do to get the result. Okay. Can you see the Excel file? Can you see it? Can you see that? Can you see the file? Okay, so this is the table we have, right? And then you want to find A and B. That is what you want to do. So in order to find A and B, you need to use this formula. You need to find B, you need to find A, right? In order to find A and B, you need to find the sum of the derivations. So you need to use these ones to get the sum of the derivations, right? Understand? So you need to find the xxx, xxy, xyy, all right? In order to get xxx, xxy, and xyy, I need to know the sum of xi squared, the sum of xi yi, the sum of yi squared, the sum of xi, and the sum of yi. So I need to find the x squared, I need to find the y squared, and I need to find the x times y. Like that. You get you do it for all the observations, and then you can find the sum. You can find the average value. Okay. Okay, now you want to find the x-axis, and that is the sum of xi squared minus the sum of xi all squared divided by 5. Okay. Then you get the sum of xi yi minus the sum of xi times the sum of yi divided by 5. That you can do. And then you get the sum of yi, right, square, minus the sum of y all square divided by 5. You understand? That's all right, everybody? Is this okay? Okay. And this is what you get. Is that all clear, everybody? That's all right? Okay. So I can say that I can get the all these values and can find the value of b. B is simply the xxy over the xxx. That is the one. And A is simply y bar, the average value of y minus b times the average value of x. Okay? Is that all right? It is okay. It is okay? Okay. So you get this, you get the value of a, right? How about n squared? In order to find the n squared, you need to know the sum of squares, right? The sum of squares give you you have the SSA, that is what you need. And in order to find that, you need to find the SST first, which is the XYY in this case. And the SSR is simply B times the XSY. Okay, that is what you have here, right? That the SSR is B times the XSY. Okay, and then you can find the sum of squares for residuals, which is the difference between the other two sum of squares, right? So that is the SST minus the SSR. And then after that, you can find the S squared, which is this divided by the degree of freedom. And the degree of freedom is 3. There are 5 observations, so the degree of freedom is 3. It is okay. Okay. So you get 0.39 for S squared. Now we are ready to find the SA and SB. What is SB? SB, if you have a look at this formula, you see that it is the square root of the S square over the x-axis 0.15. Okay. Okay, is that clear? And then you can see that the SA is the square root of the S square times the average value of xi square over the s-axis, right? And you get the SA. Okay. Now we can find the SA, the error for A and the error for B. What is the T value in this case is 3.182. You can use the software or the tables to get that number, right? Suppose that the confidence level is 95%. So I can say that it is just 95% here, and this area is 0.025, right? And the T distribution we are using has the degree of freedom 3, so you get the number 3.182. That one, and then you can see that the T value is 3.182. Okay, and then this error is simply T times the standard error, right? T times the standard error. So I can get T times the standard error, and then T times the standard error. Okay. All right. Furthermore, you can also find the R square, which is the 1 minus SSE over SST, or let's say SSR over the SST. That is the one you get. R square is 0.97, so the value, the model is really good. Understand? It is a good model, right? Okay. Now we can from what we calculate here, you can say that y equals a plus bx, so 73.81 plus 15.55 times x. Okay. And for that is y and x, that is the linear regression. You can also get the confidence interval alpha equals 73.81 plus or minus the error, so 6.06, and beta is what's that, 15.55 plus or minus 5.07. Do you understand? That's all clear. It is okay, everybody? All right. It is okay, everybody? Okay, so I think that's everything you need to know in this chapter for the final exam, right? In the project, you need to use not just a simple linear regression model. You may think about nonlinear model. You may think about multiple regression model. Okay. All right. And I think that's everything you need to study for the final exam. Is there any question? Any other questions? Yes, there will be some. There will be a T class. There will be a test. Yes. All right. Okay, let's have a break. And then after the break, during the break, you may think about the project, the materials. We want to think about the exams. All right. And then after that, I will ask. You can ask any questions about them, and then I will answer your questions. All right. About everything related to the course, right? About the materials, about the quizzes, about the exams, about the project, right? Okay, let's have a break. Hello, can you hear me, everybody? Hello, can you hear me? Hello? Okay. Do you have any questions so far? Do you have any questions? Do you have any questions so far, you guys? Guys? Yet? So you have no question about the project, no question about the quizzes, no question about the exams, right? I think, are you sure about that? Well, actually, the exam will be from, we'll cover everything we learned from the beginning to the linear regression. That's right. But you may say that, you study two parts, right? You study probability and you study statistic. And 80% of the 20% of the score will be about probability, and 80% will be about statistic. Okay. And the format will be a combination of multiple choice and written test. It's okay. All right. Do you understand? So the format is that it should be a combination of multiple choice and written test. Okay. That's good. Which part is good? Okay. Do we have quiz 7? Yes, we do. We do have one more quiz. Will we have a T class? Yes. Actually, today I will give some review about that first, and next time, no, next week we will not have any class because of the holiday. So I will give you another time, another schedule, so that we can have a TA class after that. All right, and yeah, we should have another TA class. Is there any other questions? Any questions, guys? Okay, any other questions? Okay, so if you have no questions, do you have a question about projects? Do you have any questions about projects? You guys? No? Don't, right? So if you don't have any questions, then I'm going to give you the following example. And please tell me your answer. Can you have a look at the question and tell me what you have to do? Can you get the answer? What is the median and the IQR? Do you know how to get the answer? Question A and the question B, do you know how to solve the problem? You don't need to find it, okay? You don't need to do calculations. Today, I only want to focus on the main idea, okay? The method. So just tell me the way you do it to solve the problem. You can try the problem at home. And then next time, we will go over the calculations. Yes? Do you have a question?
Teacher, there's a question in the post chat, but I haven't heard from answer from you.
Oh, which one? Let me see. Oh, there are lots of questions. I didn't see it. Well, that is an open book exam. If you need a closed book, well, then you don't need to use a book. Believe it or not, it will not be harder. It's just like it is, you're allowed to use any materials you like. You're allowed to use dictionaries. You're allowed to use textbook, your notes, and the questions. You believe it or not, the questions are not tricky. Very straightforward. So as long as you understand the materials, you should be able to solve the problem. Okay. The test is from the first chapter. That's true. So as I said, 20% is about probability and 80% is about statistics, right? How do you weight the score of the quizzes in midterm and final score? Well, it depends your scores. In fact, so I will have a look at the quizzes, your final score and your midterm scores, and then for the first part, like the first few quizzes will be used for to update your score in the midterm, and the quizzes from the chapter confidence interval, then hypothesis testing, and overall linear regression will be used to update your score in the final exam. Okay. For the projects, you just submit it, and then there will be no presentation, but there will be adjustment day. On that day, you need to. There will be a meeting, and then I will ask you about 4 or 5 questions, and if you can answer the questions, then that is good. That's all. I will ask questions about the project. Look, I will ask question about the project. So if you don't understand anything about the project, your score will be low. Understand? Okay. If you can understand about everything, then the maximum score will be 9, right? And if I ask one extra question and you can answer that, then you can get 10. And besides, you can get bonus score if you have your own data set. Okay. New method in the assignment. It means that you allow to use any kind of method, any methods you want. You can, because in the class we only study one way and over. In your project, you are allowed to use, and you are encouraged to use, 2-way and over, 3-way and over. You are encouraged to use multiple linear regression model. You are encouraged to use nonlinear regression or logistic regression. Okay, anything you want. Okay. Even if you want to use something like machine learning, deep learning, something like that, if you want to talk about that, that is fine, as long as you understand what you are doing. Is that clear? The point is that you shouldn't use some too simple method, just like you have a data set, you give me a data set, and you say, okay, this is a confidence interval for that parameter. That is not good enough. That's the point. Okay. The more method, the fancier the method, the higher the score. But you have to keep things in balance, because if you do something too complicated and you don't understand what you're doing, then your score will be low. Do you understand? So it is a combination of the understanding and the method you use. Is that clear? So you just answer my question. You don't need to present the project. As long as you submit it, I will look over and see what you can do, and then I will ask questions to make sure that you understand what you're doing. That's all. For the hypothesis, well, that is I don't know how to answer the question, because you know, you think about what you have to do in reality. It is not just so please think about what you can do in reality, in practice. Let's say there are a lot, there are several, you have a data set, right, with several factors, and you want to compare them. So you need to check the conditions you want, the conditions of the method you want to use. For example, in class, you are given a problem saying that the two samples follow a normal distribution, but in practice you don't know it, right? No one gave you that assumption. You cannot assume anything. So you are given a data set and you want to use t-test. You have to check for the normality. You have to do it by yourself, right? And if you want to use z-test, you want to check the normality as well. Or if it does not follow normal distribution, you have to make sure that the sample size is large enough, right? So you need to draw the graph of the data set, right, to illustrate what you want to do. Or if you want to use ANOVA, you may want to check the assumption, right? You need to read the materials, you need to read books, or you can go over the internet to get it, to check the to read about the assumption of the method. So you need to check for the normality. You need to check for the quality of the variance, right? Or the independence, something like that. So there's several things that you have to go over. Not as simple as you did in the exam or in class. Understand? And you have to use R. You have to use R. Is that okay, everybody? Any questions? That is fine, right? Okay, let's go over the problems I just gave you. The following table lists the monthly sales and advertising expenditures for all of last year by a digital electronics company. And there are 12 months here. You want to compute the median and the IQR of the monthly sales. You don't need to do the calculations. Just tell me what you have to do to get the median. What should we do first? Just say it. We can type in the task box if you cannot turn on your microphone. What should we do first when you compute the median? Just tell me the key point. That's all. What should I do to get the median and then the IQR of the sales? That is true. You have to arrange the values. Okay, remember to do it. The median is the one at the middle, but you have to arrange the values in increasing order. All right. Okay. Otherwise, you will get it wrong. Right. That is true. And then after that, you split it into two subsequences, and then you get another middle points. And then you get until you get the Q1 and Q3, and you look at the difference between them to get the IQR, right? How about the linear regression line? Do you know how to get that? I think may I skip this one because it is similar to what we just learned, right? For question C, all you have to do, suppose that you get y equals a plus bx, then you need to find y of 105, and that is a plus 105 times b, right? And then you can get the answer, okay? On the mean, because for the model, if you go all the way back, let's see, we have it here, no, maybe not. The model we have here is that the mean of y, given the information, will be alpha plus beta times x. Okay, that is what, well, this is the model we have. So the mean value is actually alpha plus beta x. Okay. Okay, may I move on, you guys? May I move on to the next question? Okay, let's have a look at the following problem. To find out whether a new serum will arrest leukemia, a kind of cancer, 9 mice, all with an advanced stage of the disease, are selected. 5 mice received the treatment and 4 do not. Survival times in years from the time the experiment commenced are as follows. At 1% level of significance, can the serum be said to be effective? Assume the two populations to be normally distributed. What do you think? What is the method that we want to use in this case? Should I use linear regression model? Should I use ANOVA, Z-test, or t-test? Which method? And t-test ANOVA, you think that we should use ANOVA in this case? Well, not ANOVA, in fact. Why? Because you use ANOVA for more than 2 groups. In this case, you have only 2 groups. So we shouldn't use ANOVA because ANOVA require a lot of conditions. Okay, the t-test and z-test require less conditions. That's why you should use z-test or t-test. Now, please tell me, should I use t-test or z-test in this case? So many of you said that you should use t-test. Now, is that t-test for 2 samples or 1 sample? Is that t-test for the case of 2 no variables, no the variance values, or no variance values, or and they are the same or difference? You need to mention all the conditions. There are many cases here, right? There are many subcases, and you need to mention all the conditions. And also tell me the hypothesis you want to do. No. So actually, in this case, you see, you can check to see that the sigma square, sigma 1, there are two groups here, right? And sigma 1, sigma 2, and no, you don't know them. You don't know the population variance values, right? Now, can I assume that they are the same or different? Are they the same or different? Can you tell me? Are they the same or different? So we should use t-test, that is true. But we need more details. Are they the same or different? Okay, two samples. That means, all right, okay. Yeah, that's true. The hypothesis is true. You got the hypothesis correctly. How about the two variances? Are they the same or different? Are they the same or different? Should I say that sigma 1 and sigma 2 are the same or different? Why is that? Do you know why? Can you tell me the reason? Can you tell me the reason? No, that is not. That's not right. That is not correct. If they are not the same, you can also use t-test. Yes, you can. That's true. Okay, that is true. So if they are not the same, then when you can use the formula, the following formula. Let's say the standard error. If they're not the same, all right. If sigma 1 and sigma 2 are not the same, then the standard error is simply square root of s1 square over n1 plus s2 square over n2, and you need to find the degree of freedom, right? Which is the ratio, something like that. And if they are the same, you have to find the full value, right? Let's say you need to find the n square, and then you get the and then you can find the standard error, which is the square root of sigma square 1 over n1 plus 1 over n2. This is s square, right? Well, if they are the same, then we use this approach, this formula. If they are not the same, you use this formula. All right. So how do you know if they're the same or not? What I'm saying is that if you had this, then you use this formula. If you have this, then you use that formula. Okay, and you have to check it. It is not just simply an assumption. You have to check it. You have to find ways to verify that. Okay, you cannot guarantee that, but you can check. There's a way to check it. All right. In the projects or in practice, you may want to use something like the core test, something like that, the covariance, to check for the covariance. But in the exam, you simply use the rule of thumb. You find S1 over S2. And in this problem, you can find S1 for the first group, S2 for the second group. And you can compute the ratio and you can check to see that it is about, I think it is 1 point something. And it is between 0.5 and 2. Therefore, we can assume that they are the same. Do you understand? Is that clear? Is this all right? Okay. So Bao is correct. Okay. Yeah, correct about the condition. You need to do it. You need to use this rule of thumb to check for that. This is not the best. This is not the best method. In fact, it is just an okay method because it is easy to use, but it is not really accurate. And you should use some other methods in practice, in reality. All right. Okay, and I believe that you can solve the problem as long as you can determine the case, right? Let's move on to the next problem. Let's have a look at this problem, and please tell me the method you want to use to solve the problem. Okay, now please have a look at that and tell me the method you want to use in question A. Should I use ANOVA, regression, t-test, or z-test? Can you get the answer? Do you know how to solve it? Can you get the answer? Do you get that, you guys? Get that? Okay. Is that hard? Is that hard? It is difficult. I'm still waiting for you. Okay, so you calculate the standard deviation of two samples and use two sample t-tests. And in this case, the equivariance case, two sample t-tests. I think you guys asked the wrong answer. Okay, you have to ask the first question. The first question to ask in this case that are they dependent or independent? Okay, that is the question you need to ask. Are they dependent or independent? Back to this. Are they dependent or independent? In this case, the two samples are independent, right? Treatments and no treatments. Understand? So each mouse receive a treatment or a placebo treatment. Understand? In the second problem, you have two dependent samples. Do you understand? Okay, you have two dependent samples. They are dependent. Okay, why? Because these two values are about the same individual, right? Its piece, it did in the solution and after you measure it before and after storage, right? Therefore, they are dependent. And if they are dependent, we don't need to ask question about are the two valence values the same or not. We don't care because we don't use these two samples. We use the difference. We compute the difference between the two samples, right? You compare the difference between the two samples, and you come up with a single sample. That is the difference between the two samples. Understand? And then you use t-test. Yes, I agree. But this for this t-test, the degree of freedom is only 4 because there is only one sample after all. You have 5 observations, 5 values. Okay, they are the difference between of these values. So you have only 5 values, and you have one sample with 5 values, and the degree of freedom is 4, and then you can perform the t-test. Do you understand? Do you understand? Is that clear? So long it's right. In the second row, they use the same style of ham. That's why you need to look at the difference. Okay? Is that all right? Everybody? Okay. Now, determine a 95% confidence interval for the mean acid residuals of harm in harm after 60 days of storage. So in this case, should I deal with the before storage row, the after storage row, or the difference row? Which one? The after 60 days of storage row, right? So the after storage should be the one. You use those values, okay? You use those these numbers to construct a confidence interval. All right? Is that clear, everybody? Okay. Okay, I think that's enough for today. Next time I will move to some other questions, and then you may want to try this problem. I'm going to upload the video, and you should watch the video and then try to solve the problems with more details. And next time we can discuss about the calculations if you need it. Okay. All right. Thank you very much. And please double check the calendar for the quiz. Okay, there will be a quiz, and please double check on that. Right, and you will have about 2 days to submit the quiz. Okay, thank you very much, and see you next time. All right, goodbye.